What do you mean by this allied angles? Two angles are allied together as a sum or difference of 0 or multiples of pi by 2. The function changes to its co-function whenever the angle is written as a sum of pi by 2. It is same as the angle when it is written as a sum of 3 pi by 2. The function remains same for pi and 2 pi, and depending upon on which quadrant the angle lies, the function value is positive and negative. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are going to study few more concepts about trigonometric functions. So previous session we have defined all the trigonometric ratios in terms of unit circles. We have defined the domain, range, and we have studied the graph of trigonometric functions. Now coming to the signs of trigonometric functions, we have also studied how the trigonometric functions will change its values as positive and negative in different quadrants. Now we will see the sign as well as the function in different quadrants using the concepts of allied angles. So here we will study the trigonometric ratios of allied angles. So what do you mean by this allied angles? Two angles are allied together as a sum or difference of 0 or multiples of pi by 2. These angles are called as allied angles. When I say multiples of pi by 2, it may be 0, pi by 2, pi, 3 pi by 2 as well as 2 pi. Any angle in unit circle can be expressed as a sum of pi by 2, pi, 0, 2 pi as well as 3 pi by 2. So based on the sum or difference as well as based on which angle or in which quadrant, the trigonometric function will change its sign positive or negative as well as function to its co-function. Now when I say it as a co-function, the function of sine whose co-function is cosine. And when I say tan, the co-function of tan is cot, which is cotangent. And when I say secant, the co-function of secant is cosecant. So these are the co-functions. Now here we have already studied in the first quadrant all functions are positive. In the second quadrant sine and cosecant is positive. In the third quadrant tan and cot are positive, and in the fourth quadrant cos and secant are positive. Suppose I express any other angle except 0, pi by 2, pi and 2 pi, any other angle as the sum of 0, pi by 2 or pi or 2 pi, sum or difference. So according to that we will decide the value and sign of the functions. Now allied angles ratios of pi by 2 minus x and pi by 2 plus x. So we know that here is our pi by 2. When I say pi by 2 plus x, all the angles lies in the second quadrant. When I say pi by 2 minus x, all the angles lies in the first quadrant. So therefore any angle as pi by 2 minus x will have positive value only. But when I say pi by 2 plus x, except sine and cosecant, all are negative. Like if I take sine pi by 2 plus x, sine pi by 2 plus x is same as cos x. So here the function changes to its co-function whenever the angle is written as a sum of pi by 2. It is same as the angle when it is written as a sum of 3 pi by 2. Now when I say secant pi by 2 plus x. So I told you whenever the function is added to pi by 2, the function changes to its co-function. So therefore secant should change to cosecant function and pi by 2 plus x can be written as x. Since secant x is negative in the second quadrant, we will get the value as minus cosecant x. Suppose I take tan pi by 2 minus x. When I say tan pi by 2 minus x, the co-function of tan is cot x. And what about the sine? Pi by 2 minus x means it lies in the first quadrant. And in the first quadrant, all functions are positive. So therefore, tan pi by 2 minus x is only cot x. Cot pi by 2 minus x can be taken as tan x. Similarly, cos pi by 2 minus x can be written as sin x, because co-function of cos is sin and pi by 2 minus x can be written as sin x. About the sign, cos is positive in the first quadrant. But what about cos pi by 2 plus x? Cos pi by 2 plus x can be written as sin x. But since cos is negative in the second quadrant, our answer is minus sin x. So this is how we will define the function when we have pi by 2 minus x and pi by 2 plus x. Next, we have an allied angles in the form of pi minus x and pi plus x. So this is our pi. So this can be taken as pi plus x, which lies in the third quadrant. In the third quadrant, only tan and cot are positive. So if I write tan pi plus x, tan 180 plus any angle, then it is same as tan, and tan is positive in the third quadrant, so therefore the function remains same here also. But when I write sin pi plus x, it is equal to minus sin x, because sin is negative in the third quadrant and it remains same. Function will remain same, but only sign changes. When I say secant pi plus x, then it is minus secant x. Next, we will take the ratio of 3 pi by 2 minus theta, 3 pi by 2 plus theta. So, it is same as x here. So, 3 pi by 2 minus theta means this is our 3 pi by 2 here. When I say minus theta, it comes in the third quadrant. So, here we are taking in the form of minus theta. Here we are adding plus theta. So, therefore, it lies in the fourth quadrant. In the third quadrant, tan cot is positive. In the fourth quadrant, cos secant is negative. Suppose I write tan 3 pi by 2 minus theta. So I told you, when you have any odd multiples of pi by 2, function should change to co-function. So therefore tan function changes to cot function. But what about the sign? Tan function is positive in the third quadrant, so therefore it is tan theta. Similarly, cot 3 pi by 2 minus theta is tan theta. Function changes to its co-function. Cot is positive in the third quadrant, so therefore it is plus tan theta. But if you write sin 3 pi by 2 minus theta, then it is minus cos theta. Because sin is negative in the third quadrant, and since we are taking the difference and sum of odd multiples of pi by 2, function changes to co-function, so sin changes to cos. When you have cos, cos changes to sin. Similarly, secant to cosecant, cosecant to secant. Only pi by 2 and 3 pi by 2 function will change, and sign depends on the quadrants. So next we will take the angle 3 pi by 2 plus theta. So 3 pi by 2, so this is our 3 pi by 2, and any angle added to it will comes in the fourth quadrant. So let's see now, let me take cos 3 pi by 2 plus theta. So when you are adding any angle to 3 pi by 2, cos changes to sin theta. What about the sign of cos? Cos is positive in the fourth quadrant, so therefore it is sin theta. Suppose I take secant 3 pi by 2 plus theta, then it is cosecant theta. What about the sign? It is positive because secant is positive in the fourth quadrant. Suppose I take tan 3 pi by 2 plus theta, then it is minus cot theta. Similarly, if I take sin 3 pi by 2 plus theta, then it is minus cos theta. So, because sin is negative, and since we are using 3 pi by 2, function changes to cos. Next, we will take the allied angles in terms of 2 pi. So, here is our 2 pi. So, 2 pi plus theta means it comes in the first quadrant. 2 pi minus theta means it comes in the fourth quadrant. But here, the function will remain same. Only the sign changes. For example, sin 2 pi minus theta is same as sin theta. But since sin is negative In the fourth quadrant, we will get it as minus theta. So here, suppose the same function is taken in the form of plus theta, then it is sine theta. Because when I say 2 pi plus theta, this comes in first quadrant, sine is positive in first quadrant, so therefore the value is sine theta. Now suppose I take cot 2 pi minus theta, it comes in the fourth quadrant, but cot is negative. When I write cot 2 pi plus theta, it is cot theta. So therefore, this is how we will see the allied angle ratios. Now, the very important thing here is to observe that function will change in pi by 2 minus theta, pi by 2 plus theta, 3 pi by 2 minus theta, 3 pi by 2 plus theta. Whereas, function will remain same in pi minus theta, pi plus theta, 2 pi minus theta, 2 pi plus theta. So, whenever the function changes for odd multiples of pi by 2, change it. The function remains same for pi and 2 pi, and depending upon on which quadrant the angle lies, the function value is positive and negative. So now using all these concepts, let us solve few problems and find the values of trigonometric functions. First one we have, find the value of other 5 trigonometric functions. Cos x is equal to minus 3 by 5, x lies in third quadrant. When I say x lies in third quadrant, we know that here only tan and cot are positive. That means the value of tan and cot should be positive. Other than this, all are negative. So we have here cos x is equal to minus 3 by 5. We need to find sine, tan, cot, cosecant and secant. Cos is given. We can directly write secant x because secant x is a reciprocal of cos x. So therefore it is minus 5 by 3. Now using the identity cos square x plus sine square x is equal to 1, I can write sine square x is equal to 1 minus cos square x. But what is cos x? It is minus 3 by 5 whole square. So 1 minus 3 by 5 whole square, which we will get it as 1 minus 9 by 25. So therefore we will get sine square x is equal to 16 by 25. So taking square root on both sides, I'll get sine x as plus or minus 4 by 5. Now, what sign should I choose? Whether should I take plus 4 by 5 or minus 4 by 5? Now they have clearly told x lies in third quadrant. That means sine is negative in third quadrant. So therefore, the value of sine is minus 4 by 5. Now we know cos is minus 3 by 5, sine is minus 4 by 5. We can take tan. So therefore, tan x is sine x by cos x. So therefore, the value of sine is minus 4 by 5. Value of cos is minus 3 by 5. 5 cancels. Minus minus cancel. It is 4 by 3. And cot x. Cot x is reciprocal of tan, which can be written as 3 by 4. Or we can also take it in the form of cos by sine. Next question we have, secant x is equal to 13 by 5. X lies in fourth quadrant. So when I say x lies in fourth quadrant here, so in fourth quadrant, cos and secant are positive. All other trigonometric functions are negative. So therefore, secant x is given. We can write cos x because they are reciprocal to each other. Now we can find sin x using the identity cos square x plus sin square x is equal to 1. Sin square x is equal to 1 minus cos square x. So sin square x, we will get it as 1 minus 25 by 169, which will be in the form of 144 by 169. Taking square root on both sides, we will get sin x as 12 by 13 plus or minus 12 by 13. Now, since sin x lies in fourth quadrant, it is negative. So therefore, we will get sin x as minus 12 by 13. So sin is given, cos is given. So we can write tan x. Tan x is the ratio of sin by cos. So that is minus 12 by 13 whole divided by 5 by 13. 13 cancels. We'll get it as minus 12 by 5. Because tan is negative in fourth quadrant, we'll get the value as minus 12 by 5. Now, cot is a reciprocal of tan. So, therefore, it can be written as minus 5 by 12. Next question, find the value of trigonometric function. So, here angle is given. So, this angle can be written as a form of a allied angles. Now, how? Cosecant minus 1410 degree. I already told you, always express the angles in the form of 2n pi plus or minus x, because it is same as plus x or minus x. So, when you have sine 2n pi plus x, it is same as sin x. When you have cos 2n pi plus x, it is same as cos x. So, any angle can be represented as a sum of multiples of 360 into any angle. So, now here first we have this in the form of cosecant minus x. What is cosecant minus x? So, except for cos and secant, for negative angle, all are negative of the trigonometric function. So, therefore, it is minus cosecant x. Now, let's write this. We have this in the form of minus cosecant 1410 degree. So, minus 1410 degree. So, now here we have minus cosecant. So, this can be written as 360 into 4, 360 degree into 4 minus 30 degree. Because 360 into 4 is 1440 degree. So, 1440 degree minus 30 degree gives you 1410. When I say 360 into 4, so it's a multiple of 360. Where does it comes here? So, it will come here only. So, 360, 720, 360 into 3, 360 into 4. All angles will lie on the same position whose value is same. So, it is in the form of 2 pi minus theta now. So, 2n pi minus theta. So, therefore, this value can be written as minus of minus cosecant 30 degree. Why minus cosecant 30 degree? Because when I say 360 into 4 minus 30 degree, it comes in the fourth quadrant. In the fourth quadrant, cosecant is negative. So, therefore, write this in the form of minus cosecant 30 degree. What is the value of cosecant 30 degree? Cosecant 30 degree is 2. So, therefore, minus of minus 2, which becomes 2. So, this is the value of cosecant minus 1410 degree. Next, tan 19 pi by 3. So, tan 19 pi by 3 can be written as tan, write 19 by 3 in terms of mixed fraction. So, 19 by 3 means it's an improper fraction which can be written as 3 6 are 18 plus 1 remainder. So, this can be written in the form of 6 pi plus pi by 3. So, this is same as tan pi by 3. So, tan pi by 3 means tan 60 degree. So, what is the value of tan 60 degree? It is root 3. So, same value you will get for 19 pi by 3. Why? Because 19 pi by 3 comes on the same position where tan 60 lies. Next, sine minus 11 by 3. Sine minus of 11 pi by 3. Sine of minus x is written in the form of minus sine x. So, therefore, this can be written as minus 7 11 pi by 3. Now, here 11 pi by 3 can be expressed in the form of 4 pi minus pi by 3. So, you can clearly see here 4 3s are 12 pi minus pi, which will give you 11 pi by 3. When I say 4 pi, it again comes in the position where our 2 pi lies. So, any even multiple of pi will comes at 360 only. Now, at this position, so 4 pi minus pi by 3 means obviously it lies in the fourth quadrant. So, in fourth quadrant, sine is negative. So, therefore, this can be written as minus sine pi by 3. Now, minus of minus means plus. So, we will get sine pi by 3. What is the value of sine pi by 3? Root 3 by 2. Next, prove that sine square pi by 6 plus cos square pi by 3 minus tan square pi by 4 is equal to minus half. So, first let me consider the left hand side of the equation, that is sine square pi by 6 cos square pi by 3 minus tan square pi by 4. So you need to study the standard values of all standard angles for different trigonometric function. Then only you can solve these kind of problems. So therefore you have sine pi by 6 whose value is 1 by 2. Since we have sine square, it is 1 by 2 whole square. Cos pi by 3 is 1 by 2, so whole square. Tan pi by 4 is 1, so 1 square. So we have 1 by 4 plus 1 by 4 minus 1, which is 1 by 2 minus 1, which is equal to minus half. That is the right hand side of the given equation. Hence, proved. Next, prove that 2 sine square pi by 6 plus cosecant square 7 pi by 6 cos square pi by 3 is equal to 3 by 2. Let me consider the left hand side, that is 2 sine square pi by 6 cosecant square 7 pi by 6 into cos square pi by 3. 2 into sine square pi by 6 means 1 by 2 whole square. I don't know the value of 7 pi by 6, but I can write this as in the form of pi plus pi by 6. And here we have cos square pi by 3, which is 1 by 2 whole square. Now here pi plus pi by 6. So here is our quadrant. So this is our pi. When I say pi plus pi by 6, it comes in the third quadrant. In the third quadrant, cosecant is negative. So therefore, we have 2 1 by 2 whole square plus cosecant pi plus pi by 6 means it is minus cosecant pi by 6. We have whole square outside, so square. And here it becomes 1 by 2 whole square. Now we have here 2 into 1 by 4. Cosecant pi by 6 is 2 minus 2 whole square becomes 4 into 1 by 4 here. So when you solve this, you will get 2, 1 by 2. Here you will get plus 1. Half plus 1 is 3 by 2. So that is the right hand side. So today we have discussed few concepts of allied angles and how to find out the value of different trigonometric functions. We'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.